about standard deviation and variance, and here is my explanation of that. I am using a website that I frequent, and you may have already heard me talk about this. Mathisfun.com is one of my favorite websites to go to find information on different math topics. So I'm going to use what they have to say about standard deviation and variance. And right below the title, standard deviation and variance, you see there's like a subtitle, and it says deviation just means how far from the normal, which is absolutely true. We're talking about standard deviation of a data set. We're talking about how far each number in our data set is from the norm or from our average or mean. So the standard deviation is just a measure of how spread out our numbers are. It has a symbol. If we're talking about the population standard deviation, then the symbol we use to denote that standard deviation is going to be the Greek letter sigma, and that's that green symbol right there. Okay, that's if we're talking about the standard deviation of a population. If we're talking about the standard deviation of a sample from a population, then you're going to just use the letter S to denote standard deviation. Now, the formula for standard deviation, which we're about to go over, is actually quite easy to compute. But when you look at it at first glance, you're going, what? It looks very scary. It's not that scary. It's actually pretty easy. It is going to be the square root of the variance, which is why those two are so closely related and why they're taught together. The variance is calculated by the formula that you see under the square root symbol. The scary part of the formula for standard deviation is the formula for the variance. We find the variance. After we find the variance, then we take the square root and we get our standard deviation. They're very closely related then. What is variance? The variance is defined as the average of squared differences from the mean. The average of the squared differences from the mean is the variance. How do we calculate that? Well, here's how we do that. First step is take the data, take your numbers in your data set, add them up, and take the average or the mean. So if you have 5 numbers in your data set, you're going to add those 5 numbers up and divide by the number of numbers, which is 5, to find the mean or the simple average of your numbers. Once you've done that, then you're going to take each individual number from your data set. And from each number, you're going to subtract the mean that you just calculated. So each number minus the mean, and you'll get a difference, right? For each number in your data set. Those differences, you're going to take them and you're going to square them. After you've squared the differences, then you're going to find the average of those squared differences. So you're going to take the squared differences, add them up, and divide by the number of numbers. Once you've done all that, you have your variance. The next step will be to take the square root of your variance and you have a standard deviation. So here's an example. You and your friends have just measured the heights of your dogs, and you're measuring those dogs from their shoulders down. You see the little red symbols that kind of look like triangles with a tail. Those are just marking the spot where the dog's shoulder is. Okay, so if you look at the Rottweiler, his shoulder shows that his height is about 600 millimeters, and that's our first number in our data set. The next dog over is at about 470 millimeters. Then we have 170, 430, and 300, and those are all marked on that chart. For these 5 dogs' heights, we're going to find the mean, the variance, and the standard deviation. Let's first do the mean, calculate the mean. So we're going to add those 5 heights up. 600 plus 470 plus 170 plus 430 plus 300. We get 1970. Then divide that number by 5. When we divide that by 5, we get a mean or an average height of 394 millimeters. We plot that on that same chart, and that is the green line that you see here. That green line is representing the mean of 394 millimeters, and it is about smack dab in the middle of all the heights of those dogs. Now, of course, we have a couple dogs that are way above and way below. Our Rottweiler's way above the line, and the Dachshund is way below. But that's why we're going to find the standard deviation to show and represent that not all of our dogs are right there at that height, right around that 394. Some of them are a little smaller dogs, and some of them are larger, but in the end, the average comes to 394. We're going to calculate the difference, each dog's difference from the mean, so the difference in their height from the mean itself. And we do that by saying, okay, the first dog's height is 600 millimeters. We're going to subtract from that our mean, which is 394. 600 minus 394, we get a difference of 206. Then when we go to the next one, we have 470 minus 394, which is 76. And then we have 170 minus 394, which is negative 224. 430 minus 394 is 36. And 300 minus 394 is negative 94. Those are the differences from the mean. Now we're going to square each of those differences. Okay, so we square the differences: 206 squared, 76 squared, negative 224 squared, 36 squared, and negative 94 squared. And we get these results: 42,436, 5,776, 50,176, 1,296, and 8,836. Add those up and divide by 5. When we add those numbers up, we get 108,520 divided by 5, and that gives us a result of 21,704, which is the variance for these 5 dogs' heights. Variance is 21,704. After we find the variance, the last thing we need to do is take the square root of 21,704 to find the standard deviation. When we do that, our answer is approximately 147.32, and rounded to the nearest millimeter is 147 millimeters. The good thing about the standard deviation is that it is useful. Now we can show which heights are within one standard deviation, or 147 millimeters from the mean. And using the standard deviation gives us a standard way of knowing what is normal or average and what is extra large or extra small for a dog's height. Rottweilers are going to be considered a little bit extra large and extra tall, where Dachshunds are going to be considered extra short. We can expect, when we're dealing with standard deviation in our data sets, we can expect that about 68% of values will be within plus or minus 1 standard deviation from the mean. 68% of our values will fall in that range that you see in this chart here, the blue shaded range. And we will talk more about the normal curve and where all of our data points fall within, the area under the curve here in the next video lesson. But let's talk about one more thing with standard deviation and how we calculate it. There is going to be one simple, small change that happens if we're talking about sample data instead of a population. Our example that we had above was for a population. The 5 dogs that we were talking about were the only ones we were interested, so it was a population that we were finding the standard deviation for. But if that data was a sample or a selection taken from a bigger population, the calculation changes just slightly. When you have n data values that are the population, you're going to divide by n when you're calculating the variance, just like we did in our example. However, if you have n data values that are a sample of a population, you're going to divide by n minus 1 when calculating the variance. All of the other calculations, of course, will stay the same. So, using our example above, if our 5 dogs were actually just a sample of a bigger population of dogs, instead of dividing by 5 like we did, we would divide by 5 minus 1, which is 4. So we would divide by 4 instead of 5, and here's what we would get. Our sample variance would be 27,130, and the standard deviation would be 165 millimeters. And here are those two formulas. If you're talking about a population standard deviation, it's going to be 1 over n times the sum of the squared differences. If it's a sample standard deviation, you're going to have 1 over n minus 1 times the sum of the squared differences. Okay, and then take the square root of those formulas. It looks complicated, but the important change is to divide by n minus 1 instead of n when we are calculating a sample standard deviation.